All right, let's get into it. Today, we're going to peek behind the curtain at the invisible intelligence that's secretly running pretty much every building we use every single day.
You know that feeling, right? You're sitting at your desk, you're in the zone, and then bam, you're suddenly freezing. Or maybe you're overheating, but the person just one desk over is putting on a jacket. It feels totally random, doesn't it?
Well, it turns out you're not crazy. It's not random at all. There is a complex system, a kind of secret brain, making thousands of little decisions every single minute, right behind the walls. And that's exactly what we're going to break down.
So, let's talk about this secret brain. What is it really? And what is it in charge of?
The official term is a Building Automation System, or BAS for short. The easiest way to think about it is as the Building Central Command Center. It's this whole network of computers and software that's constantly watching and controlling everything. The AC, the heat, the lights, you name it.
Now, this is where things can get a little confusing, because you'll hear a ton of different acronyms thrown around. BS, BMS, BEMS, but here's the key. Don't get bogged down in the jargon. For the most part, they all point back to the very same idea, that single, central brain running the show.
Okay, but a brain isn't much good if it's just sitting in the dark, right? It needs a way to feel what's going on. It needs a nervous system.
And that's where sensors come into play. I mean, they are everywhere. They're measuring temperature, humidity, CO2 levels, even detecting if you're actually in a room. They are the eyes, the ears, the nerve endings of the entire building, feeding this constant stream of information back to the brain.
And it's not a one-size-fits-all kind of deal. The system uses all these specialized sensors for different jobs. For just general room temperature, you probably use an RTD. They're super accurate and stable. But for the ice-cold pipes in the chilled water system, you need something way more sensitive, like a thermistor. And for crazy high heat, like inside a boiler, you need something tough that can power itself, like a thermocouple.
So the brain has its senses, and it's getting all this data. How does it actually process all that information and decide what to do next? Well, it thinks using something called control loops. There are really two basic ways to control anything. First, there's open loop. Think of an old traffic light that's just on a simple timer. It's going to turn red every 60 seconds, whether there are 100 cars or 0 cars. It gets no feedback. But the smart way, the way these systems work, is closed loop. That's like your smart thermostat at home. It's always checking the room's temperature. That's the feedback, and adjusting the heat based on what it senses.
And this closed loop is basically the building's reflex. It happens over and over, thousands of times a day. First, a sensor senses the room temperature. Then, the brain compares that reading to where you want it to be, let's say 72 degrees. It then calculates the difference, the error. And finally, it acts, sending a signal to do something about it, like opening a valve to let in more cool air. Sense, compare, calculate, act, over and over again.
So, after the brain senses and decides, it needs a way to actually carry out its command. It needs some muscle. In a building, those muscles are called actuators. They're the ones that do the physical work. When the BAS sends out an order, it's an actuator that actually gets its hands dirty, physically turning a valve, pushing a damper open, or flipping a big switch.
And these are the real workhorses of the whole system. You've got actuators that open and close valves for water pipes, others that adjust these big flaps called dampers inside the air ducts, and even things called variable speed drives that can tell a giant fan to spin faster or slower.
So, okay, we've got a brain, a nervous system, and muscles. It's all very cool technology, for sure. But why does any of this really matter? What's the actual payoff here?
Well, how about this? 25%. Studies have shown that just by fixing control problems that already exist in these systems, you can get energy savings of up to 25%. That's not a small number. That is a massive amount of energy and money. And when you look at how a building actually uses energy, this makes total sense. All that heating, ventilation, and air conditioning, the HVAC system, that can be half of a building's entire energy bill. So yeah, making that system smarter is the biggest lever you can possibly pull to save energy.
So the crucial thing to remember is a well-run BAS isn't just about the money. It's about keeping people comfortable and happy. It's about reducing the wear and tear on really expensive equipment so it lasts longer. And it means the people who run the building can spot a problem and fix it, maybe before you even knew anything was wrong.
You know, this quote from the source material just says it all perfectly. The whole game is a balancing act. You want to keep people comfortable and breathing clean air while using the absolute least amount of energy possible to make it happen. That's the sweet spot.
And here's the really exciting part. This technology is not standing still, not at all. That building's brain is getting smarter and smarter every single year.
I mean, think about where we've come from. It started with just simple, local thermostats on the wall. Then we got these centralized systems we've been talking about. But right now, we're in the age of the Internet of Things, big data and machine learning all getting integrated. And what's next? We're talking about true AI and digital twins, perfect virtual copies of buildings where we can simulate and perfect strategies before we even try them in the real world. So the next time you're in your office and you feel that little blast of cold air, remember that invisible brain working away behind the scenes. And then ask yourself this: what happens when that brain stops just reacting to the world and starts predicting what we need before we even know we need it? Thanks for tuning in.